Hey everyone. So in this video, we're going to be talking about the tips and the tricks we need to ace our chemistry examination. And we're going to be talking about some keywords that are going to help us understand the question better and that are going to help us write better answers for the exam so that we don't end up losing marks. Remember one thing, the questions are designed in a way to confuse you. So you need to filter out the excessive details and you need to pick on the right keyword that the question is asking. So let's talk about this first. When you're reading the question, make sure you have your pencil in your hand because while you're reading the question, it's more important to underline the words that the question is using so you write the exact thing that the examiner wants you to do. For example, if you're talking about describe, if the question says describe, you don't have to use your own previous understanding. So you don't, let me write it, you do not use your own previous knowledge. For example, description of graph questions. For example, description of some kind of chemical analysis. For example, description of some chemical phenomena. You don't have to use your own understanding. You can directly give a very explicit, very categorical answer in simple sentences. Don't be too wordy. Don't try to use much loftier English. Just write in simple words required with required keywords. Don't use your own understanding. Don't try to give reasons for things. When the question wants you to explain, this is where you use your understanding. So you talk about the chemical processes. You talk about, for example, the reasons behind some chemical phenomena. This is where you use it. When they want you to name, this is where people make a very silly mistake. I don't think it's a big blunder. People make a silly mistake over here. They write the chemical formula instead of the name. Why would you do that? So read that if the question wants you to write the name, and make sure when you're talking about transition metal compounds, the Roman number of oxidation state is a part of the name. For example, you're talking about copper sulfate. So if you write copper sulfate, that is wrong. You need to write copper 2 sulfate. So you need to write copper with 2 in brackets and then sulfate. The 2 is from the Roman numbers. So copper 2 sulfate. This is how you write. Make sure there's no space after the copper and the Roman number. But that is okay. At least you write the number. When you write potassium manganate, it's nothing. It doesn't exist. I know it exists, but make sure you're writing potassium manganate 7. So there's no such thing as a manganate. You need to write potassium manganate 7 or sodium manganate 7 or just manganate 7 ions. So this would be the right thing to write. So when you want to write the name, make sure you write this. When they want you to suggest something, that's an open-ended question. So you can use your own understanding. You can write the chemical formula. You can write the name. That is both okay because they're not asking for it. TKG. So you can do that. Another set of questions that often confuses people is from electrolysis. When they sometimes ask you for naming the product, they sometimes ask you for talking about the ions which are moving or the ions which are oxidized or reduced or whatever. They sometimes want you to write the equation. They sometimes want you to write the observation. So this is something that messes your marks over here. Make sure when they want you to write the products are generally elements. Like copper is an element produced on the cathode, chlorine as an element, oxygen as an element, hydrogen gas as an element. So these are elements, these are products. Write the name over here. Name them. When they want you to write the ions, make sure you're writing the ion properly. For example, copper 2 plus ion is okay. If you want to write the name, copper is not an ion. There's no such thing as copper. If they want you to write the name of the ion, write copper 2 ion. This is how you should be writing it. So make sure you're writing the correct Roman number of the oxidation state if it's a transition metal ion. If it's hydrogen, hydrogen is not an ion. You need to write it completely, hydrogen ion. People write hydrogen when someone asks them the ion and they feel really happy. Okay, we did this right. No, sorry, you did not do this right. So make sure hydrogen ion, oxide ion, hydroxide ion, you write it like this. If it's zinc, zinc ion, copper to iron, iron to iron. You need to write that. Equation, you know how to do this. Um, Equation is rarely something that people make mistakes in, so equations are fine. Observations, guys, observation. No one wants you to name the product over here. No one wants to know the name of the product. You just write the color of the gas or the solid or whatever. For example, pale green fumes, colorless bubbles of colorless gas, fizzing. These are the products. Pink solid deposits, gray, silver gray metal deposits. These are the observations. Even in any other part of the chemistry where they're asking for the observation, writing the color is more important. If you write the name of the substance, that is okay. But if you're not writing the name of the color and you're writing the name of the product, thinking about, oh my god, I answered it correctly. No, this is not how you should do it. So make sure you're writing the name of the color or the fizzing or bubbles. You're talking about this. This is people often mistaken. For example, when we talk about, I have some questions from 2019 onwards, because 19 onwards the mode of questions, the marking scheme has changed a lot. So let's pick on some questions and let's see how they've changed it. For example, this is one of the questions. It says magnesium reacts with aqueous copper 2 sulfate in a redox reaction. They want you to identify the particle which is reduced. You can do that, but they want you to explain the answer. Now, when it's a question from redox, people used to talk about oxidation number. They used to talk about the charges. Charges is wrong. Oxidation number is correct. People used to talk about reactivity series over here. Okay, fine. But as long as you're not saying electrons gained or lost, you're not getting any marks. So you need to talk about electrons are gained or lost. So make sure if you write, for example, you say, by the way, which particle is reduced over here? So people write copper. Guys, copper is not reduced. Copper to ions are reduced. So you need to say copper to ions, or you can say copper plus 2 ions. So people write copper is reduced and they feel happy about it. The particles which are reduced or oxidized are always on the left side. So you need to say copper ions are reduced. Copper can't be reduced. It's already in a zero neutral state. It can't be reduced any further. And in the explanation, you need to talk about electrons gained by copper 2 plus ions. People do that. Electrons are gained by copper. Copper is not gaining electrons. Copper ions are gaining electrons. So please be aware of that. Another question, for example, yeah, dot and cross diagrams. Dot and cross diagrams are a whole load of I don't know what, but they're really hard to check. So when you talk about dot and cross diagrams, people do it right. Okay, a lot of people do it right, but there's one mistake that makes them lose 1 mark out of 3 or out of 2. And for example, let me draw it. If I want to draw the dot and cross diagram of phosphorus trichloride, I would draw 1 circle for phosphorus. I would draw 3 circles for chlorine like these. These are my 3 circles over here. And I would label them. For example, I would label them like phosphorus, chlorine, chlorine, chlorine. I know phosphorus makes 3 bonds because it's group 5. So dot, dot, dot. And then for chlorine, I would be like, okay, cross, cross, cross. People do this and they're happy about their answers. Guys, you need to make sure you don't forget the lone pairs, or you can say the unbonded electrons. So people forget about the unbonded electrons. Phosphorus is in group 5. You drew only 3 dots. There has to be 2 more dots. So there are 2 electrons of phosphorus which are not involved in bonding right now. Chlorine is in group 7. It's got 7 electrons in the last shell. You have drawn only 1 electron of chlorine so far. So you need to make sure you draw the unbonded electrons like these. They always go in pairs, but at least draw them. Make sure you don't forget them. So while you're drawing the dot and cross diagrams, don't forget the unbonded electrons. This is the kind of question that has been repeated since last 2 years a lot, and people write their answers based on their understanding, but they don't actually understand the question, what it's saying. It's saying, use the kinetic particle theory to describe. Now you want to describe something. You don't have to give the reason. You have to describe the changes. So they're talking about the changes in movement and arrangement of the particles when solid becomes liquid. So they want you to talk about the movement of solid and movement of liquid and arrangement of solid, arrangement of liquid. So you need to talk about first, let's say I start with movement. So you have to talk about that a movement in solid was vibratory motion, particles were doing to and fro motion. Then say movement of liquid. Then in liquids, the particles are sliding over each other in layers. Then talk about arrangement, that in arrangement, solids were regularly arranged in a lattice. In liquids, they are having an irregular arrangement. You don't have to give reason over here. People lose their marks because they give a load of reasoning over here, that they had stronger attractive forces, heat was absorbed, attractive forces were overcome, attractive forces were like they overcome the attractive forces, particles get wider distances. Don't do that. People lose their marks over here. This has been a question that has been repeated like 3 times in the past 3 years. Make sure you're not doing that. Maybe 3 or 2 times or more times, but this question is very repetitive now. So make sure you're prepared for this kind of question. Another question from bonding. Guys, bonding is just a chapter about keywords. There's no such thing. You have been studying it like since 5th grade. What's different now? It's about the keywords. So for example, if they're talking about sand, which is SiO2, and they're talking about structure and bonding, so your answer needs a reference to the structure and a reference to the bonding. For example, you need to talk about the structure. Now, I'm not basing my answer exactly on silicon dioxide, but structure could be structures. Example of the words for structure, you can, for example, it could be giant ionic lattice, depending on what kind of substance they're talking about. It could be giant metallic lattice. These are the keywords that could be used for structure. It could be a giant covalent molecule or giant covalent lattice, or you can say molecule. It could be simple covalent molecule. So it could be simple molecules. These are the words that can be used for structure. For bonding, you can talk about electrostatic attractions, you can talk about van der Waals forces, you can talk about weak intermolecular forces. But you need to use the correct keyword. If you don't do that, you end up using marks. One thing that people also do wrong is they talk about weak intermolecular forces and they talk about breaking them. If you're using the word intermolecular forces in an answer because you feel that is the right word, it's not breaking. Intermolecular forces are always overcame. You always overcome them. They're always overcame because you make sure that weak intermolecular forces are overcome. So make sure that this is what you should do. Over here, another mistake that people do is when they talk about covalent bonds are broken. So you break covalent bonds. People write strong covalent bonds are there and these are overcome. Guys, we don't overcome bonds, we break them. We don't break intermolecular forces, we overcome them. The correct keyword should be used. Intermolecular forces overcome, strong covalent bonds broken. So make sure you do that. Electrostatic forces are also forces, so they are also overcome. Make sure you use the correct keyword in these kind of answers. One thing that I also identified, molecular formula. So this is something they've changed over the past few years. When you are talking about the molecular formula, people end up writing it in a structural way. They do this with carboxylic acids, they do this with alcohols. In molecular formula, you can't use the same element twice. For example, people write it like this. Si, they write OH2, then they write C2H5 twice. That is wrong. If you write it like this, even for example, Si2H2, and then they write C2, or for example, write C4H10, That is also wrong. You don't have to give reference to the structure. The correct formula should be Si, then there are 2 O's, there are 4 C's, and there are almost 12 H's. Make sure you do that. Each element can be repeated only twice. For example, in carboxylic acid, people write it like this, CH3COOH. If I'm writing the molecular formula, that's wrong. You need to write the molecular formula like this, C2H4O2. This is the molecular formula. I'm not saying that you can't write it in an equation. But when the question comes to write the molecular formula, this is how you should write it, C2H4O2. You don't break the C's, you don't break the O's. Make sure you keep that in mind. Another dot and cross diagram, make sure what I told you. Remember what I told you about the lone pairs or the unbonded electrons. There's another question about metallic lattice. You can see that there's a question 8 part B. It says, describe with the aid of a label diagram the metallic lattice, the metallic bonding. I know you can describe it. I know it too well that you guys can describe it really, really amazingly. But when it's diagram, people draw it like this. And they write the plus charges over here. And then they draw the electrons like these. Guys, this is wrong. If these are positive charges, how are they touching each other? You need to make sure there are very minute gaps, not too large gaps, but there are very minute gaps like these. Let me draw it here. So you draw them like these with very minute gaps. And then you draw the positive charges, and the electrons can be in the spaces like these. So you draw the electrons like these. So you make sure that metallic lattice is drawn with very minute gaps between the positive charges. I'll figure out more of these kind of errors that people do, and I'll try to compile them as well. Stay tuned, guys. Thanks.